Oh, hi Big Sky students in Greater YouTube. You caught me in a nap. It's been a long year. I'm tired, but also so impressed with all the amazing projects that occurred in the DT space this inaugural year. Boxes, so many boxes. Cubbies, signs, three-dimensional milling and routing, laser engraving, plasma cutting, welding. All from innovative Fusion CAD designs and captured in creative Adobe Premiere videos. We explored the tools, the processes, and have come so far together. I'm really proud of you and your accomplishments. In celebration, I took what I've learned throughout the year and built a plaque in honor of an amazing individual who has shaped the school and community we all enjoy. I thought I'd share that journey with you as your second semester and third trimester box videos have come together. Let's go. Every project begins in the design phase. This project was complicated by having two distinct parts: a woodworking project similar to a cutting board and engraved sign, and then a milling operation to create the aluminum centerpiece. I used Fusion to make an overall model to see how they would nest together. You can see the woodworking portion of the project modeled here with walnut as a border and white oak as the centerpiece. Then the aluminum block embedded into the surface. This model was created early, so there were some changes as I moved along. Most obviously, I had thought a copper inlay between the two species of wood would be cool, but I just couldn't figure out the finishing to make both the copper and the wood look professional in the end. Maybe down the road. There were some other changes to the aluminum model as I iterated the design to successfully come out on the mill. I started with the aluminum portion, so the inlay it would embed into on the woodworking project would be a precise fit to the wood base. As this is a circular object, work holding, which is the very important aspect of milling where the part needs to always be held securely in the machine, becomes a challenge. This requires that the part be milled from both sides and precisely lined up in the middle. You have to create all of the cutting operations or tool paths Fusion is going to program for the mill to operate. This means considering what type of tool path you're creating, the type of tool you're going to use, the RPM that tool is going to spin, the depth of the cut for each pass, and how fast the tool is going to move across your part. These are called the feeds and speeds. The first step on this project was to mill the bottom. This starts with a facing operation using a face milling tool to create a clean and perfectly flat surface. Then I used a 1/2 inch end mill to carve the circular shape into the bottom half. Finally, I drilled and tapped 4 holes on the base so I could bolt a custom-built jig to the bottom of the part to clamp the now circular bottom in the vise on the Haas mill. This custom jig was a quick project with a quick cut on the metal bandsaw on some scrap stock and then 4 quick drilling operations to perfectly line up the holes with the tapped threads on the centerpiece. Once the bottom operations were done and the piece was clamped using the work holding jig into the vise and the piece precisely located in the machine, it was time to work on the top. That precision using the probing features on the mill is accurate to a 1/1000th of an inch. Again, we start almost any milling operation with a quick face mill. Then I use the same 1/2 inch end mill to cut the circle out to match the bottom. With that done, I moved on to milling the Bighorn logo external shape onto the piece. This was accomplished with decreasing bit sizes from 1/2 inch to 1/4 inch to 1/8 inch sizes to remove the most material with the larger bits, but then provide precise shaping with the smaller bits. This uses a process called rest machining, where the tool paths are calculated by knowing what previous operations have happened, so they only remove the material the larger bits couldn't reach due to their larger radii. This same technique was applied to removing the material to leave Bighorn letters raised. This time it was 1/2 inch, 1/8 inch, and finally 1/16 inch bits for really tight accuracy. At this point, the aluminum block is in its final shape, but the logos need to be engraved and all of the 90-degree edges need to be chamfered so they're not sharp to the touch. These operations occur on different z-axis planes that are zeroed by the probe before each operation. The part that's produced is shiny, but shows lots of tool marks and other distracting marks. Lots of experimentation into aluminum polishing and finishing has happened this year. We decided for this piece, a brushed look for all but the raised letters was going to look best. Lots of sanding, polishing, and buffing later, it's ready. Now it was time to build the wooden portion of this project. Just like the box projects you built this year, this starts with milling the rough stock walnut and oak by using the chop saw, jointer, planer, drum sander, and table saw. Once all the pieces were square and roughly the same thickness, I used the crosscut sled and a 45-degree jig to cut the corner angles in the walnut. Once everything was cut, I glued it all together, and once the glue was dry, I rough sanded it flat. This project required both sides to be engraved, so it was off to vCarve to make the proper tool paths for the router table. The back side needed pockets for the bolts that would attach the aluminum piece, and also for hanging brackets. The front had some text to engrave and circular inlay for the aluminum to fit nicely into this wooden base. Once I had the tap files, I took to the router table to run these programs. Painting, sanding, finishing, and voila, a project to be proud of that hopefully is representative of the hard work of the recipient. Such a heavy plaque needed a stand to properly display it. I designed a trivet stand in Fusion, created the cutting tool paths, and sliced 3 16-inch steel on the plasma cut. Then I welded the two pieces together, did a lot of grinding due to not being a great welder yet, and finally spray painted it black. One thing I'd like to show are all the iterative designs, test pieces, and mistakes that went into this project. Every time I failed or felt something was too hard, I revisited the Teddy Roosevelt quote I've shared with you throughout the year. I left a lot of dust, sweat, and blood in the arena, dared greatly, and know victory in this worthy cause. Enjoy your summer! I can't wait to progress our skills and build amazing things with you next year.